Hello, good afternoon, everyone. Can you listen to me?
Hi, good afternoon, doctor.
How are you all?
Fine, how are you?
So, actually, there is some problem with my camera. It's not possible to turn it on. Let me share the slides with you. Can you see my screen?
Yes, doctor.
Can you see these slides, Spring 2022?
Yes.
Okay. So, okay, 1 minute. I have to disconnect my other screen. Just a minute. Okay, so now you can see it.
Yes.
So my name is Madia Safdar, and I am your lab instructor for this semester for EE312 course. The course is Electronic Devices and System, and the course code is 312. Okay. For spring semester, I will be assisting you, guiding you for the lab activities, and we will be performing some experiments which will be based on both simulation and hardware. Okay, are you guys familiar with the simulation, multi-sim software? Do you know what is this? So okay, so
I
this
don't remember.
Okay, it's okay. So multi-sim is the main software which we will use for all the simulations of the circuits, and then we will also perform the experiments in hardware. So I will guide you that today is only introductory class, and we are not going to start any experiment today. Next in the next class you will be coming to the campus, all of you, and there will be no online activity. There will be no Zoom link posted on the Moodle. Only all the students, you have to be in the campus, so that we will be performing mostly we will be performing the hardware experiments. Okay, and simulation, I will tell you how to perform the simulation on your own. That will be counted as a pre-lab. Okay, so lab activity total, this is composed of 15 marks. It means that 85% marks you will get from your lecture. I think your course instructor is Dr. Murugapan, and he will be responsible for your theory, lecture activities, midterm, final exam. That is, he is totally responsible for that, and I am responsible for 15% of your marks. Okay, and that 15% is further divided into two different, which is 10% is for the lab reports. It's written here, lab reports, and 5% for the lab final exam. Okay, so almost there will be 6 different experiments. At the moment there are 6 experiments, and then one lab report is further divided into this grading scheme, that 2% will be for the pre-lab, which is all simulation, which you will be doing it at home. Before coming to the lab, you have to do this part so that you can get 2 marks for it. Those students who will not submit the pre-lab, they will get 0 marks for these two. Okay, then class participation, it means that you will participate in the class in such a way that if I am doing some hardware experiment for you, then you guys have to perform it yourself. You have to try it, but I will be guiding you, but you have to perform the experiment, because there will be 30 students, and then I will be coming to you one by one, but it will be better that if you can do some of the steps yourself. I will guide you. I will guide you in the beginning. Okay, that is the class participation. If I see any student, I can ask questions also during the class activity. And if some student is unable to answer, or if I can see some student is not participating at all in the groups, then that student will not get these marks. Okay, Then final lab report submission will will get 4 marks. So 2 plus 4 plus 4 will be equal to 110. So 10 marks for this. You have to fulfill all these three things, okay, in order to get full 10 marks. So then I will divide you in groups, okay. So I will ask you in the next lab that who wants to make group, like group of 3 students, okay, who will be performing the lab, okay. And you have to coordinate together to make groups, okay. So 3 people per group. These 3 people will be performing the experiment for all the semester together, and then you have to submit the individual lab report, but you have to specify me the names in the next class, and then I will write it and post it on the Moodle that group 1 is this 3 students, group 2 is these 3 students, so that I will know that all of you 3 students will have the same lab report. Because if there is a same lab report between 2 different groups, then that will be marked 0. So that will be very strict, okay. So in the next lab, please coordinate between yourself and tell me that which 3 people wants to do the lab together, and they will be submitting the same lab report, okay, so that you don't get deduction of your marks based on copy, okay. Is it clear to you all?
I have a question, please.
Yes. Yes.
Is it obligation a 3 persons group?
How many you want?
Alone, please.
But how you will
If
perform the
it is
experiment
possible.
alone?
If it is
You
possible.
will submit the report alone.
Alone.
But
Is it possible?
it is possible, but the work activity will be shared during the class. The lab activity, it's not possible to, like, for me also it will be difficult that I teach only one student the lab activity, I repeat for the other student only one by one. It will be not possible for me, and then we don't have so much equipment in the lab, so you have to perform the experiment in group.
Yeah, I think if they, yeah, go ahead.
Yes, and then you will submit your lab report individually. Okay, but group is important so that I don't deduct your marks for copy. That is for
I know, but what is the useful of the group?
the use of group is to prevent the deduction of marks based on copy. If there are 2 different groups, for example, 3 group in one, 3 students in one group, 3 in another. If 2 groups have same lab report, there I will deduct the marks.
Okay, for my case, I don't know any students.
It's okay. You will, all of you will come to the lab. I will make the groups. It's okay.
And also, if the student he make the pre-lab, he will. I think the time and the energy for you will be less. If they did the pre-lab in simulation, the lab will be easier and fast to do the practical.
Yes, that is for sure. Pre-lab activity, all of you have to do it at your home, and then you have to submit it in the Moodle before coming to the lab. That is important.
Submission before we come.
Yes, before you come, one day before. For example, today is Wednesday. You have to submit your pre-lab on Tuesday, midnight, 12 a.m. Okay?
Okay.
So that is important. I will post separate links for pre-lab, separate links for the final report. Okay?
Okay.
Yes. Then that's it.
Sir? Please, I want to ask if I couldn't come for one lab because I have a cancer patient, my brother. Sometimes I should be with him in the hospital. So what if I couldn't come to the campus in one day? What should I do?
Actually, if you will not for the labs, it's very important for all of you to come to the lab, because if you're unable to come to the lab, then you will get like you will not be able to perform the hardware experiment, and then in the final exam, if that experiment is coming, you will not be able to perform it. That is your
I'm
own.
no, I mean, just if 1 week or after 3 weeks, just one time. I don't know about the appointment with the hospital. If it is in the same time of the lab, what should I do? Can I do it again in different section?
Yes, that I have to ask the other section, because there is another instructor, engineer Hala Shihada. She will be responsible for the lab activity for section 2. I am for section 1. There are only 2 sections. I can ask her if you can come to her lab, but if that is also not possible, then you should come to me during my office hours, and I will perform the experiment for you.
Okay, thank you very much.
Yeah, no problem. Okay, so please all of you come to the campus for the lab activity, because then if you are not able to come, then you will not be able to perform the experiment, and in the final exam you will not be able to perform your exam. So that's important. Yes, 4 students can also be in one group. That the groups we will discuss in the next class. When you all of you, when you will be present in campus, then we will make groups. I will see the capacity of the table, how many students can sit on one table. Then according to that, we will make the groups. Okay. So these are also some instructions for submission of your lab in the Moodle. Please submit all your lab assessments in the Moodle, and you have to submit only on the Moodle. If you will submit me by email, I will not be able to accept it unless you have very solid reason. But instead of emailing me, you can just submit it on the Moodle, and it will be counted as a late submission. Okay, so there will be deduction of marks again for the late submission. So better that you submit the lab within the 3 days. I will post the deadline in 3 days, so that because I have to mark the reports also, so that I get also time, and then I have to prepare for the next lab also. So 3 days will be sufficient for you to submit your lab report. Okay, so that I get time for grading and preparation of the next lecture. And yes, this is important. If 2 different groups submit the same lab report, that will be marked 0. Okay, for both of them. So it's better don't copy, only copy for the group, and then I will have the names of the groups, and then that will be okay. So this is a multi-sim environment. This is the software which we will be using for making the circuits. For example, resistors, capacitors, BJTs. So these all components are available here. Okay, we will be using this software to make all our simulation work here. So are you guys familiar with this software? Some of you.
Yes, doctor.
Yes, good. So it means that many of you would have this software in your laptops also. So those who don't have this software in your laptop, if you just go to the Moodle here, this is the 312 Spring 2021 course. So in the announcement, you can see that there are general lab instructions. And here, this is the video for installation of, if you click it in the next tab, this video will open. Okay. So this video will have all the steps to download the multisim software. And then when you install the software, at the end, you have to put this license so that your software becomes active. For activation, you have to put this license key. Okay. Then there are also this PDF instructions, how to download multisim. First of all, you have to go to this link. For example, here. So first you will sign up from here. Okay. Sign up. And one thing I have to show you here, that this is the thing where you will, for example, your email ID is, let me annotate. For example, your ID is 21312 @ student dot KCST. Okay, so this is the number which you will put here. Okay, without this you will not put it here. Only this number you will put here. Then first name, second name, and then here you will select student, this one. Then company, here you will write KCST this, and automatically it will take whatever. Okay, city should be Kuwait. So this, and then your email ID, KCST email ID, and then password. You will create account. Then this software will send the credentials for verification of your email. Okay. Then you will verify your email. Okay. From here you will confirm your account. You will get this email in your email account. Okay. Then after that you will come back to this this PDF, and then from here you will open another link. In this link you will be able to download this software from here. Okay, from here you will download it, and then according to the instructions you will just tick this one so that you accept the agreement. Then next, and this will download, and at the end here it will ask you for the license key. The license key is here in the Moodle. You will just copy this from here, copy, and then you will put it here, paste it here, all in all these fields. Then you will click here, activate, and then next, and then that will be for that. When it is done, then you have to restart your computer, and then multisim will be active. So then you have to search for it, NI multisim, it will be active for you. Okay. So these are the steps which you need to follow in order to download the software. And then you can also create an online account, but that is not needed. For all of those students who have MacBook with you, please consult with the IT in university so that they can try to install multisim in your laptops, MacBooks. If that is also not possible, then you have to come to the library. You have to do the pre-lab before coming to the lab. Okay, so this is very important. Then so these are instructions about how you will bring the components for the MATLAB main environment, main page here. So then you have to save your project or file from here. Okay, so first this is your pre-lab. Okay, if one more thing I want to show you here is here in this folder. If you click this folder, here I have already posted the first lab sheet. So if you download it, you will get this first lab. So the first lab experiment is the BJT characteristics. Okay, so this BJT, about BJT, bipolar junction transistor, tomorrow in Thursday class, the professor will tell you what is BJT and why it is important, what is the use of BJT, what are different mode of configuration of BJT, all those theory related things he will teach you probably in tomorrow class. Thursday you have class. So then you will be, please pay attention to the lecture very carefully, because all those configuration, biasing, whatever he will teach you, I will be implementing the same thing in the lab. So please pay attention to the lecture very carefully so that when you come to the lab, you know what is BJT, what is the active mode of configuration, what is the saturation mode, what is the cutoff mode. So all of those things you should know it before, so that when we perform the experiment, you are already familiar with these things, so that we can have a discussion kind of thing during the lab. Okay. So so this is your pre-lab. So if I open it, the lab sheet here. So this here. So first one, this is the pre-lab. You will implement this circuit in the multisim. I have already implemented it here. So those who don't know, actually we will be performing this experiment during the lab also, but you can try it yourself. Try to build this circuit yourself if you have multisim. So from here you will place all the sources. For example, you need, this is a DC source. You will get it from here. You will press OK, you will get it here. Then this is the ground. So ground, from here you will get it, you will put it here. Then this is the resistor. From here you will just click this basic, and from basic you will put resistor 1 kilo ohm, you will put here. Then what you need 200 ohm resistor also, just write here 200, and this you will place it here. Then what is this? Does anyone know this?
Transistor.
BGT.
This is transistor, this is BJT. So if you see here, from here, this is transistors are here, and you have to put this number 2N3904. Here you will write it, and then you will take it. So then you will build this circuit. Okay. I delete all of these because I don't need. So according to your lab sheet, if you come here, all the instructions are written here. Okay. Design a simple transistor circuit given. So when you are done with building this circuit, the next step is to save the lab. Okay. So how you will save it? Lab 1, pre-lab. And then the extension will be MS14. You will just save it. So now this is saved. Okay. Then you will come here, simulate, analysis and simulation. So here you can see that source 1 VBE. Start value is 0, stop value is 2, and increment is 0.1. Start value is 0 for VBE, stop value is 2, and increment is 0.1. So when you will start, you have to tick this box so that this source 2 is active, because you have two sources in your circuit. There are two sources. So the second source VCE, voltage of collector to emitter is 2 volt. Start is 2, 12 and 4 is the increment. So 2, 12 is the stop, and 4 is the increment. You will first save it, and then you can run it from here. Then you see this kind of curve will come. So in your lab sheet, first you have to see for 2 volt, then 6 volt, then 10 volt. Okay, so if you click here, it will become white. So so first you want only for 2 volt. So uncheck all of this. This is for 2 volt. Then with the cursor, yes, from here, you can put it here. So from the cursors, here this is written that, okay, so first VB 0.1. Write the value of current. So you will move the cursor. Yes. So you see X, this is X-axis, this is Y-axis. So this is current here. This is the voltage across base emitter. Okay. So this is 103.86 millivolt. It means that this is 0.10 volt. You will just shift the decimal towards this. This is milli, so 0.103 volt. At 0.1, how much is the current? The value of current is here. Minus 2.32 pico ampere. It means almost zero current. Almost zero current. So then according to this, you will move the cursor, and then you will write the values of current. Here you can write 0 because pico is very less value, 10 raised to minus 12 means 0. So then you will move it, and from here you will check it according to these. Then next is 6 volt. So you will uncheck this. 6 is here. You will check this graph. Okay. Then same, you will move the cursors, and then you will fill the table here. Okay. Then from the characteristic response plot. So this I will do in the next class, but this is saying that for 14 volt. So what you will do is you will come back here again. You will go to simulate analysis. So here you will put it 14 volt. Then you will run it. So this is, and then the 14 volt will come here. You will check this and you will uncheck all others. So this is for 14. This graph you will just, for example, whatever black or white you want, you will just copy this graph, put it here. And then this simulation, but it is not compulsory that you do all this experiment yourself in the next class. I will guide you in the next class because you don't have any knowledge about BJT. I assume that you don't have yet any knowledge about the BJT. First, you will study it in your lecture class tomorrow, and then in the next class, I will explain some of the theoretical things to you, and then we will start this so that you get idea that why we are doing this, why we are solving this all the table, and what does this graph means. Okay, why we are getting this graph. Okay, so that things, those things I will explain you during the next lab. Okay, please all of you come to the lab. That's very important. Then, so this is the lab. F004 is the lab where we will be meeting every Wednesday from 2 to 4. So you can see that these are the tables. Here we have this power variable power supply. Then this is the oscilloscope. This is the breadboard where we will put our components here. Same like this. Here we put our components to do the simulation, and we will assemble our components on this device, which is known as breadboard, and we will connect it with the power supply. And then this is the function generator. We will not be using it at the moment. And then here in the computer, you can open multisim also. So this is the lab setup, right? Then, so these components already you must be familiar. So in the first lab experiment, we will be using two different resistors. One is 100 ohm and other will be 1K or 1000 ohms. Okay. So you know that this is all of you. Do you know that this is resistor? Right?
Right.
Okay. So there are different color bands on the resistors. You can check the resistance of the resistor using multimeter. So meter, you can check how much is the resistance of this resistor by multimeter, or you can check the resistance of the multimeter using the bands. Okay. So first, yes, first color is whichever, for example, this is yellow color. So yellow is 4, right? For this, 4
Right.
is the first digit. Tell me what is the second digit. So second digit will be which number? 7.
7.
Yeah, 7. And then
7.
now the
Number.
third digit is the
Number of zeros.
yes, multiplier, number of zeros. So third color is red. So 2. 2 means 2 zeros. Okay. Then the fourth band is, this is the multiplier, and then this is the tolerance. Okay. Yes. So how much is this resistor?
4.7K.
Yes, because you can just shift here 4.7 into 10 to the power 3 ohm or 4.7K. Okay, so this table will guide you how to check the resistance of a resistor using the color bands, or you can use the multimeter. I will guide you how to use the multimeter to check the resistance of the resistor. Okay. Then, so this is a multimeter. With this, you can, if you turn this knob here at ohms, then connect one terminal with the first leg of resistor. For example, this is the resistor here, and second here, it will give you the resistance of the resistor. Okay. Next, what is this?
Transistor.
Yes, this is the transistor, and if you keep this side flat side, it has one rounded side, if you know. One side is flat, other is rounded, the other side. If you keep a flat side towards you, then this will be the emitter, this will be the collector, and this will be the base, this will be the collector. Okay, so the symbol is this. Emitter is always shown with this arrow. Okay, so you provide the signal at the base, and then the current from collector to emitter starts to flow. Can anyone tell me, like, if you have knowledge about transistor, that this is controlled by voltage or current?
Current.
Transistor, yes, very good. Transistor is a current control device. Okay, we control current at the base, and then we monitor the voltage from collector to emitter. Okay, so it can amplify, amplify the voltage and
Switch.
yes, switching. Yes. Then, so this is the breadboard. Here we will put our transistor. Here we will put our resistor. So can anyone tell me, if I connect one leg of resistor here, one here, what will happen?
The same, short.
Shorted, yes, good. But always I will connect my devices in this manner, always like this. Never you will put your devices like this. If you will do it like this, then it will be short circuit. It will be shorted. There will be always you will put it in this manner. Okay. So then this is the power supply. So you will increase. This is variable power supply. Means that you can give any voltage from according to the capacity. For example, if this is designed for 24 volt, 0 to 24 volt, you can get any voltage from this variable power supply. Okay, you can vary the voltage. Then, so these are the hookup wires. We will be using it in the breadboard to connect with the supply, and connect the components together. These wires we will use, and these are the wires. If we want to connect the multimeter, if we want to connect the external devices, we will be using these wires. These are jumper cables. These are the hookup wires. Okay. Then this is the last slide, because today is just a light introduction. So here, please pay attention to the lecture. So check that there are different regions of operation of a transistor. Okay, that is cutoff region, active region, and saturation region. Okay, so when the transistor is in active region, that is used for amplification. When the transistor is in saturation or cutoff region, that is used for switching. So in detail, we will discuss it in the labs, but in the next lab experiment. But it will be very good if you pay attention to tomorrow's lecture, so that you have an idea what is transistor and what does these different modes of operation of transistor means, so that in the lab you can perform very well. Okay, so that's it for today class. So if you have any questions, ask me. It's up to you if you perform this lab. It's up to you, but I will explain you this curve in the next class when you will have some knowledge about the theory. Okay?
Okay.
At least build the circuit yourself and then bring it. One more thing that is very important is if you go here in Google, you have to, do you know, are you familiar with OneDrive?
No.
So if you write onedrive.live.com,
Yes.
it open, because this is very important for all of you, because you can copy your pre-lab in the drive, so that you don't have to bring your USB, you don't have to bring your laptops to the lab. Okay, so sign in, and here you will use your KCST email ID. For example, whatever is your ID, 1122@student. Okay, .kcst.edu.kw, and then you will make next, and then you will put your password. Then this OneDrive will be active. For example, for me, this is So you will see that it will take me to the KCST. Yes. See, I put all my documents here in the drive so that I can access them anywhere in the world. So that I don't have to like bring USB everywhere. All my documents are here. Desktop, I can access all of these things. So please, when you do the pre-lab, upload it in the drive from here. Upload files. Okay, for example, you solve your pre-lab on the desktop. For example, I solved this lab. I will copy it, I will open, and it will upload in my drive. Okay, so that when you will come to the class, I will ask you, okay, show me your pre-lab, show me your circuit. You will directly download it from here, and then you will start working on it. This will be very easy for you. Okay.
Okay.
Clear? So
Clear.
please make your OneDrive active. And one more thing, that I will upload this video for today lecture also on the Moodle here. I will put it in the announcement. Only this video will be available here. Next, I will not be posting any video, so that you can make your setup for the next lab. Please prepare yourself well for the lab. OneDrive, your this multisim, everything. Please make a setup for yourself, and so that next class we will be very active and we should be starting our experiment with full knowledge of the theory. Okay, that is important. Okay.
Okay.
So I will hint, I will upload the video now. You can see the steps for the lab, but this is not compulsory for you to bring the pre-lab for the next lab, because I will show you all the steps in the next class. In the next class, we will perform the first experiment. Okay.
Okay.
Inshallah.
Yes. So that's it from my side for today. So see you in the next class on Wednesday from 2 to 4 in campus.
Inshallah. See
Okay.
you.
Yeah. Thank you. Bye bye.
Thank you. Bye. Bye.
Bye.